But this today I'm going to discuss on the same class 10th. Name of chapter is light, and this is a we can say part 2. Previously part 1 where I have discussed with you what is a concave mirror, convex mirror, important term called as the center of curvature, radius of curvature, focal length, pole, right? F is equal to R by 2 and all. So now here I am going to discuss today key image formation, and that to be image formation with the concave mirror. So this is a discussion I will do. Image formation with concave mirror. To understand this topic better, we are having some rules here. Rules means there are some rules are there for the formation of the image. Let me discuss with you the rule. Let us say better rule number 1. Suppose we are having a concave mirror is here. And but in the concave mirror, this is called as a principal axis, point P, focus F, center of curvature C. Suppose a ray of light, I'll draw in this way. Suppose a ray of light which is parallel to the principal, this P and C is a principal axis. Ray of light parallel to the principal axis and it will be incident on the mirror. Then after incident on the mirror, it will be reflected and the reflected ray get passed through the focus. It is a rule number 1. So this is a ray of light, that is a ray of light parallel to the principal axis, incident on this mirror, and reflected ray get passed through the principal or pass through a point or pass through a focus. This is a rule number 1. Rule number 2 says that, it says that exactly opposite of this rule. If we are having a concave mirror and in this concave mirror, same way, pole P is there, center of curvature C is there, focus F is there. Let us say a ray of light that is a passing through a point F, means the ray of light, if it is passes through the focus and when it is incident on the mirror, then the reflected ray will be parallel to the principal axis. I repeat again, ray of light passes through the focus and it will be incident on the concave mirror. Then this reflected ray, see here, reflected ray, it will be parallel to the principal axis. This is a rule number 2, right? Then rule number 3 will be there. 3 possibilities there. And rule number 3 says that, suppose we are having a concave mirror. Suppose we are having a concave mirror and we are having a pole P, then center of curvature C and focus F. Suppose ray of light is not passing through the focus and all. Instead of that, one more possibility we can say, if the ray of light passes through the center of curvature and when it will be fall on the mirror, then the incident ray also passes through the same way and it goes back. Means the ray of light when passes through the center of curvature and fall on this mirror, then the reflected ray also passes through the center of curvature. This is the rule number 3. So Formation of image. See beta, formation of a image due to concave mirror can be best understood by knowing these three rules. Rule number one, ray of light parallel to the principal axis incident on the mirror and the reflected ray should pass through the focus. Rule number two, if a incident ray or ray of light when it passes through the focus and it will be incident on the mirror, the reflected ray is a parallel to the reflected ray is a parallel to the principal axis. Rule 3 says that when the ray of light passes to the center of curvature and fall on the mirror, concave mirror, then the reflected ray also passes through back to the same center of curvature. With the help of these three rules, I am going to discuss with you formation of image. So now image formation with a concave mirror, right? So this is a heading. Image formation, image formation with concave mirror. Let us say beta in this one some cases I want to give. Case 1. Object is kept beyond the sea. Object is kept beyond sea. Beta if object is kept beyond sea means I want to show you how the object will be kept at the beyond sea. Uh, it is a concave mirror and in this concave mirror the same we are having a principal axis where the point P is a pole, point F is a focus and C is a center of curvature. Let us say beta from P to F, if it is a 4 centimeter, so C to F also we have to keep the same thing 4 centimeter. Now my condition is there, I kept the object and this object is kept beyond C. This is a C. This is a C. So my object is kept beyond C means let us say this is an object kept at the beyond C. Means I should draw this way. Right? So this is object was there. That is a point A is the head of the object and point B is the tail of the object. Now for the formation of any image, listen here beta. For the formation of any image, we need to produce two rays. Let us say it is a one ray produced by the A. See beta, this ray is parallel to the principal axis. This is a principal axis. C2P, P2F or B2P. This is a principal axis. So one ray passes through the point A. It is parallel to the principal axis and it is incident on the mirror. This is the point to incident. But according to rule, when it is incident on when the ray or the parallel or the ray of light which is parallel to principal axis will incident on the mirror, then the reflected ray should pass through where? Is pass through the F focus. It is going in this way. It is the first one. Second possibility, what we can say here, from this point, one more ray I'm going to produce. Let us say, beta, this is a ray I'm going to produce here. I want to show. It is a second ray produced by this object AB, and these rays now it is passes through the point F. That is a focus. What we learn beta, the rule is that if the ray passing through the focus, then it is incident or it will fall on the mirror, then the reflected ray should become a or it become a parallel according to rule number 2. If the ray parallel to the principal axis incident on the mirror, then the reflected ray should pass through the focus. If the ray, that is a ray of light, if pass through the focus incident on the mirror, the reflected ray should be a parallel rays, which is or it should be a ray parallel to the principal axis. But due to this one, what it obtained an image. Check beta, this is the image was formed by it. This is the image was formed by it. And where the image will form, if the reflected rays actually meet at any point, that means we can say it will form the image. See beta, image is forming here. See, this is a point of the intersection, I can say. And this is the image formed by it. Let us say it is a dash and it is a B dash, right? So this is a remit. Means we can write here, just a minute, we can write here reflected rays. This is a point to remember, beta. Ki reflected rays meets at a point, then it forms the image. Then it forms the image. So for this particular diagram, what we can say is, sir, we can say what is a position of the image and what are the characteristics of the image. So with the first one, I should say what is the position and what are the characteristics of image. But the position and characteristic of image is point number one. So where the image is formed, can we say beta image is formed in between F and C, because your point F is here and C is here and image is formed here. So point number one, sir, image is formed in between F and C, in between the focus and the center of curvature. Second point, sir, how the image is, either it is a erect image or it is a inverted. So you can see A and B, it is in here, and this A and B which is shown in the black color, it is look like a inverted. So what we can say, sir, this is a inverted image. But one more point I want to tell you as a note point, ki inverted image are the real image. What is my real image? You know, if beta reflected rays, they actually meet. Yes, sir. See, this is a one brown color reflected rays will be coming here. A green color reflected rays is coming here, and they are actually meeting. If the reflected rays are actually meet, then it forms the real image. So remember, inverted image are always be the real image. Inverted image are always be a real image. But what is the size of the image? It is a very large, so we can say no. This will be compared to that one, it will be small. So I should say the size of the image is a very small. And but in physics, very small image will be called as a diminished. That is a very small size of the image was obtained. So it is a case one where the object is kept beyond C. Now we'll see beta case two where the object is kept at the point C. Case two, object is kept at point C. But object is kept at point C. Same way, the diagram how we have drawn here, the same way I will show you at the points here. This is a concave mirror. This is a point P as a pole. This is a focus F. This is a point C, center of curvature. And I'm going to keep the object is at the point C. So I should show the color of this object also. It will be looking better with the red color. It is a and it is a point P. Chalo. Then, but for the formation of any image, we have to produce how many? Two rays. Let us say one of the rays passing through, means the rays parallel to the principal axis incident on the mirror, concave mirror. Then the reflected rays should pass through the focal length F. But here distance is same, 4 centimeter. This is also 4 centimeter. Equal should be there. P to F, whatever the distance we are taking, the same distance should come as a C to F. because we kept the object at the C now, at the center of curvature. The what is another one, sir? Another one more ray I am going to produce from the A. Let us say it is a ray coming from here. Uh, Coming from here, it is coming in this way. Now it is passing through the focus and incident on the mirror. And now it is going to meet at this point. See, but it is going to meet at this point. Where the reflected ray will meet, at that point only it will form the image. So, sir, image was formed here. But this is the image was obtained here. This is a point called as a dash, and this is a point called as a B dash. So, what did you understand in this one? Second case mein, कि what is the position and characteristics of image? So I should say position and characteristics of image. Point number one. But the image is formed at C. Image is formed at center of curvature C. But how the image is? Sir, it is erect or inverted? Sir, image obtained is a inverted image, and inverted image is always be a real image, because whenever the reflected rays are meeting actually, then it forms the real. And I told you beta, if the image is a inverted, it is always be a real. Point number 4, what is the size of the image obtained by this one? So size of the image is of the same size of image is formed. We can say point number 3, or we can say it's a case 3 now. Now case 3. But in the case 1, what we did? We kept the object beyond C. In the case 2, we kept the object at C. Now case 3, we have to keep the object in between C and F. I should say object is kept in between center of curvature C and the focus F. This is a case 3. We'll try to draw this one also. We'll try to draw this one also. Just a minute. This is a concave mirror, and this is a point P as a pole, F and center of C. Just a minute. Line is not clearly drawn here. Kept in between C and F. This is a C. This is a F. If you are taking this distance as a 2 centimeter, 2 centimeter, 4 centimeter, 4 centimeter, and now I'm going to keep the object in between C and F. So object should be shown with the red color. It is kept in between C and F. So this is the object I kept here. This is a and this is a point B. And to obtain the image, what? But I should draw minimum 2 rays from it. So one of the rays parallel to principal axis incident on the mirror, which one? But a concave mirror. And now the reflected ray should pass through the focus F. Right? Now the another one, the ray passing through here, passing through the focus incident on the mirror, and now this reflected ray passing this way, and they will meet at this particular point. The reflected rays where they are meeting at a particular point, at that point only they will form the image. See, this is a dash and this is a B dash. It is the image was obtained here. So what is the position and characteristics of, so I should say position and characteristics of image are. Point number one. But where is this image was obtained? So I should say image is obtained beyond the point C. Image is formed beyond C. C means center of curvature. Second point, how the image is. Obviously, sir, it is an inverted. And just now I discussed with you, but all inverted image are the what? Real image. What is the size of this image, beta? Compared to that image, red color, it is somewhat bigger in size. So we got here as a magnified image we are getting. We are getting here as a magnified image. Now case 4. See, first case mein we kept the object beyond C, then at the C, then in between C and F. Now we'll keep the object exactly at the point F. Case 4. What is that, sir? Object is kept at focus. But when the object is going to keep at the focus, how it will be? Just think about it. Uh, this is a concave mirror, right? This is a principal axis. It is a pole P. It is a focus F. Center of curvature C. Distance between the P to F and C to F both are same. And the image is kept at the F. So show with the red color. So this is the image. That is a be kept at the F. So for formation of any image, we have to produce a two rays. But one of the rays passes through point means it is parallel to principal axis, incident on the mirror, and the reflected ray passes through the F. This is a one point. But a second ray, I should produce it from the A only. But see, beta, if the ray from the A, I cannot pass through the F in this direction. So what is that? I should draw the ray in such a way that one more condition is that, did you remember? The rule number C says that, rule number C beta, it says that if the ray, if the ray passing through the center of curvature is, see beta, this is the ray passing through the center of curvature. So when the ray passing through the center of curvature, it goes and it will reflect on the, or it will incident on the mirror. But as soon as it will incident on the mirror, the reflected ray also coming back on the same direction. See, it is also coming back on the same direction. Now what will happen? These two rays, reflected rays, are not meeting anywhere. But see beta, these both the rays are the parallel rays. Let me discuss with you. These both the rays are the parallel rays. These both the rays are the parallel rays. And you know, parallel rays, they will meet only at the infinite distance. Parallel rays, they meet at infinity. So they will meet at infinity means obviously image is not forming here. But when image is not forming here, what I should say, where the image we will get. But remember, the parallel rays, they meet at infinity means the image which is going to form, they will form the image at the infinity. They will form the image only at the infinity. But actually, it is not, these things never happen, but they are considering it is a one of the concept was that parallel rays will meet only at the infinite distance or at the infinity. So what is the position and characteristics of the image? So position and characteristics of image are, first point, but these reflected rays will meet at the infinity means the image where it will be formed. So I should say as the reflected rays, as the reflected rays are parallel rays, so they meet at infinity. Hence, image is also obtained at infinity. So where the image is obtained, beta, it is at the infinity. Point number two, how the image will be? Obviously, beta, reflected rays meeting at infrared distance means that will be rays are the, or we can say image will be the inverted image, and all the inverted image are the real image. What is the size? Sir, it is the size become a highly enlarged, we can say. Highly enlarged size of image was obtained. Right? This is a fourth case over. But one more case will be there. That is the case 5. One more case will be there called as a case 5. What is the case 5? We can say, ki I'm going to keep my object. It is in between focus and the pole. Object is kept in between focus F and pole P. It's an interesting bit on this part. Why? Because here, suppose it is a concave mirror, right, sir? This is a principal axis. P is here, focus is here, center of curvature is here. And we are going to keep the image. It is in between F and P. So in between F and P means somewhere here. It is a and it is a B. And to produce the image, I should produce two rays. First one is a ray coming from A here. It will incident on the mirror. But as soon as it will be incident on the mirror, what we learn, it should pass through the focus, right? But a second ray, anyhow, I cannot draw directly in this way to pass through the focus. So second ray, I should consider or draw in such a way, these rays are going and it is incident on the mirror, as well as consider that these rays are actually coming from the center of curvature. It is a ray coming from center of curvature. The ray which is coming from center of curvature and incident on the mirror, the rays will come back on the same direction. And now it is going backward in this way. See, beta, these rays are actually not the parallel rays, right? These reflected rays are not the parallel, they are the diverging rays, and beta, diverging rays never meet. Remember, these reflected rays in this case, beta, reflected rays are diverging. See, one is going on one direction, other going on other direction, diverging rays. Reflected rays are diverging, and and they cannot meet with each other. But they cannot meet with each other. So image is not going to form in this case. So instead of that, what we will do is just we have to produce a line from here. Think that beta, this is a line I'm going to produce here, and it is a line who can be produced somewhere, produced here. It is a line produced here. And in other case, it is a line produced here. Second one is that this is the rays. 1 second. I'll show with a different color. See, these are the rays are meeting at this point. Now, as these rays are meeting at this point means we can make here principal axis, and hence this is the image was obtained here. beta A dash and B dash. See, in this case, the image which is obtained is a upright, that is a erected image was obtained here. So what is the position and characteristics of the image in this case? The first point we can say here, sir, image is obtained where it is beyond the mirror. Image is obtained beyond mirror. And how the image will be, sir, it is a upright or erect image. It is upright or erect image. And we can say that all upright and erected image are the virtual. Means if the reflected rays are really they meet, they are the real, but here they are not meeting. We are producing the rays and we are taking somewhere to meet, so they are the virtual. And how the size will be? So size will be, it is a enlarged size of image was obtained. So this is about the case 4, sorry, case 5. And one more is there. We can say, beta, let us say, suppose I will keep object is at the infinite distance. What will happen? Just think over it. Sixth case. Object is kept at infinite distance, or we can say it is at infinity. Let us see, this is a uh, concave mirror, and this is a principal axis, pole P, focus F, center of curvature C, C to F and F to P distance is same, and somewhere object we kept at the infinity. But at infinity may suppose we kept the object somewhere. So from this infinity, the rays are coming, and these rays which are coming from the infinity, they are the parallel rays. When it will incident on the plane, incident on the mirror, the reflected rays should pass through the focus F. But another case again I want to draw, same, the rays coming from the infinity, because anyhow that rays coming from the infinity and it will incident on the mirror, the reflected rays can pass through the focus F. See, beta, when these two rays are meeting at this point F, so our image will be obtained at the point F. So image will be obtained only at the point F. So in this case, what to say? The position and characteristics of image was, what we can say, beta? Ki image is obtained at the F. Image is obtained at F. F, focus F. How the image is? Obviously, beta, whatever the image we are getting here, see, if we are keeping the object beyond C inverted, at the C inverted, in between C to F inverted, right, beta? In between F to P, we got the erected that to be outside of it. This is the case. See, image is kept in between F to P. So outside and erected. But what are the image we are keeping on the left side of the F? That is left side of the F means in between C to F or in between C to left side this side. Anyhow, infinity means it is at the left side of the C only. So image often will be always be a inverted image here. And this inverted image at the point F only we are getting. All the inverted image are the real image. And what is the size? But a very, very small size. We can say it is a point size of image is obtained at F. So these are the 6 cases are there. So overall what we learn, beta, overall we learn here when the object is When the object is kept beyond C, the image is inverted real very small. At the C, inverted real same size. In between C to F, inverted real magnified. At the F, inverted real highly enlarged. In between F to P, it is only upright, erect, and virtual. And at infinite distance, inverted real and the point size of the image was obtained. So this is the formation of image beta. Formation of image with the help of a concave mirror we have seen. In my next video, I will discuss with you the formation of image with the help of a convex mirror, how it will be. I'll explain you, right? If you like my video and all, really, if you are thinking it is useful for every children's, so please share this video for maximum number of students and please like it, share it and subscribe it. Thank you very much.